Welcome to the deep dive. We're here to cut through the noise, dig into the source material, and really extract the core knowledge for you. Today, we're diving deep into a fascinating story from World War II aviation. It's about how these big, heavy American fighters, think the P-47 Thunderbolt, the P-51 Mustang, the F-6F Hellcat, were first, well, mocked by the enemy.
Right, mocked isn't even too strong a word. You had some of the most experienced pilots in the world, German and Japanese aces in 1943, literally laughing at these designs. They looked clumsy, overweight.
Exactly.
Yeah.
But that laughter didn't last. We're tracing how that derision turned into, frankly, terror and then silence. It's really a story about how a certain kind of thinking, industrial logic, systemic production eventually overwhelmed individual skill and tactical brilliance.
That's the heart of it. Our mission here isn't just about the planes themselves, the specs and speeds. It's about the moral dimension, the psychological shift. It's a clash of philosophies, really. The Axis focus on lightweight agility and pilot excellence versus the American emphasis on survivability, firepower, and this relentless industrial machine.
We want to pinpoint that moment when the enemy realized their core assumptions were fatally flawed.
Yeah, when they understood they were facing something entirely different.
And we've got some great sources, detailed accounts, analyses covering these three key aircraft in both Europe and the Pacific. We're going to see how sheer quantity eventually became a quality all its own. Okay, let's paint the picture. April 8th, 1943. Over occupied France. You have Oberleutnant Ralph Herrmachen, a Luftwaffe ace, veteran pilot, flying probably the best fighter in the sky at that moment, the Focke-Wulf 19.
Absolutely, a superb aircraft. And he looks up and sees these brand new American fighters making their combat debut, the P-47 Thunderbolts.
And his reaction?
Pure derision. He gets on the radio to his wingman and calls them flying milk bottles. Yeah, it sounds funny now, but it perfectly captured the German perception.
Why milk bottles? What did they see?
Well, compared to the sleek FW-190 or the BF-109, the P-47 was huge. Barrel-shaped fuselage, almost 7 tons empty weight. That's, 65% heavier than the P-40 he was replacing? It just looked wrong, according to their doctrine, which prioritized nimble, lightweight designs for climbing and turning.
So they saw this massive thing struggling initially to gain altitude.
Right. And the mockery wasn't just Herrmachen. Joseph Priller, another top ace with JG-26, he dismissed them as meat for the slaughter. He had some pretty colorful descriptions, didn't he?
Yeah, the sources quote him saying, "It flies like a truck, turns like a freight train, and climbs like a pregnant cow." They even nicknamed them Indiana Fat Targets.
It really shows a mindset, doesn't it? It's not just a technical assessment, it's almost cultural arrogance. They believed their pilot skill and their optimized aircraft would always prevail over American brute force engineering.
And that same kind of thinking, that same dismissal of heavy fighters, we see it mirrored in the Pacific, right? With the Japanese reaction to the Hellcat.
Exactly the same pattern. The Japanese had taken the lightweight, hyper-maneuverable philosophy to its absolute extreme with the A6M0. Incredible aircraft in the right hands early in the war.
So when they started getting intelligence reports about the Grumman F-6F Hellcat,
Lieutenant Commander Saburo Sakai, one of their greatest aces who survived the war, he basically laughed it off. The reports described something huge, heavy. He said it sounded heavy as a bomber, wide as a transport. To the Japanese pilots who lived and breathed the Zero's nimbleness, the Hellcat violated every single principle of fighter design they held dear. It was twice the weight of the Zero when loaded.
but the American designers like Alexander Kartveli with the P-47, they knew exactly what they were doing, didn't they? They weren't trying to build a better Zero or a better FW-190.
No, not at all. Kartveli reportedly called the P-47 project a dinosaur, but crucially added, it will be a dinosaur with good proportions. They consciously traded some maneuverability for other things: altitude performance, speed in a dive, and critically pilot survivability.
Let's talk about that altitude performance. The P-47's engine was key, right?
Oh, absolutely. The Pratt & Whitney R2800 Double Wasp, a massive 18-cylinder radial engine pumping out 2,000 horsepower. But the real secret weapon, the thing that added so much weight and complexity, was the General Electric turbo supercharger.
Explain that a bit. How did it differ from what the Germans had?
Okay, so German fighters like the FW-190 and Bf-109 used engine-driven superchargers, usually single or maybe two-stage. They compress the air going into the engine, which is vital at altitude where the air is thin, but they lose efficiency the higher you go. The P-47's turbo supercharger used exhaust gases to spin a turbine, which then drove a compressor. It was a complex system, with ducting running all the way to the back of the plane.
Which contributed to that bulky look.
Exactly. But that complexity allowed it to maintain full engine power much, much higher, up to around 27,000 feet or even more. At those altitudes, the German engines were literally gasping for air, losing significant power.
So the P-47 pilots could dictate the terms of the fight: stay high, dive down.
That was the idea. Energy advantage. Always attack from above. But we have to be honest, that initial German mockery, it wasn't entirely baseless in the very beginning. That dinosaur cart Veli built, it was a real handful for its own pilots at first.
The training losses were pretty shocking, weren't they?
Staggering. Between September 42 and January 43, before the P-47 really saw major combat, the Americans lost 18 pilots and 41 of the planes just in training accidents stateside or in England.
41 planes lost before even fighting. What was going wrong?
Several things. First, that massive engine and propeller generated incredible torque. On takeoff, if you weren't careful with the rudder, it could literally flip the plane over a torque roll. Landings were tricky too, with the heavy weight and relatively narrow landing gear leading to ground loops. You needed serious leg strength on the rudder pedals.
Okay, so handling on the ground and at low speed was an issue.
But the bigger killer was compressibility in high-speed dives. Because it was so heavy and clean aerodynamically, the P-47 could pick up speed incredibly fast going downhill. As it approached Mach 0.75 or 0.8, around 500 mph airflow over parts of the wing could go supersonic.
And what happens then?
Shockwaves form. Control surfaces lose effectiveness, particularly the elevators. The nose pitches down uncontrollably, the dive steepens. Pilots called it frozen stick. Often the airframe couldn't take the stress and would just come apart.
Terrifying.
Absolutely. It took significant engineering fixes, like adding dive recovery flaps later on, and entirely new pilot training on how to handle high-speed dives before they really tamed the beast. So initially, yeah, the P-47 was dangerous even without the enemy shooting at it.
Okay, so the P-47 had its teething problems. But the moment the tide really turned, the moment that laughter died in the throats of the Luftwaffe pilots, wasn't about climb rate. It was when they shot one up, and it didn't fall down.
Precisely. The Germans were accustomed to seeing fighters disintegrate after a few good hits from their 20mm cannons. A Spitfire, a P-40, even their own Bf-109s were relatively fragile compared to what they were about to encounter.
And the textbook example of this, the story that almost sounds like legend, is Robert Johnson's flight on June 26, 1943.
Lieutenant Robert S. Johnson.
Yeah.
An incredible story. Returning from an escort mission over Lazo, France, his P-47 gets hit. Badly.
The damage reports are just staggering. 21 hits from 20mm cannon shells. Think about that. Shells designed to rip bombers apart, plus over 100 machine gun hits from a previous encounter. His canopy was smashed, hydraulic fluid was spraying into the cockpit, the engine cowling was shredded.
He's basically trapped in a flying wreck, limping home at maybe 170 miles per hour, just trying to survive.
And then a lone Fef-U-190 spots him. Easy kill, right?
Should have been. The German pilot pulls in close. Johnson described it vividly later. The German calmly, methodically, fires all his remaining 20mm cannon rounds into Johnson's already crippled P-47.
And Johnson's plane just absorbs it. It keeps flying.
It keeps flying, smoking, shuddering, but flying. The German pilot must have been completely bewildered. He then, according to Johnson, emptied his machine guns into the Thunderbolt as well. Everything he had left.
Still flying.
Still flying. And this is the kicker. The German pilot, out of ammunition, pulls up alongside Johnson's cockpit. He just stares at this impossible wreck that refuses to die, shakes his head in disbelief, gives Johnson a sort of informal salute, and then peels off and flies away.
Wow.
Johnson managed to nurse that plane back to Manston in England and landed it safely. Ground crews counted over 200 holes. It defied everything the Germans understood about aerial combat damage.
So this wasn't just about one lucky pilot. This was demonstrating a fundamental design philosophy, right? That massive structure needed to house the turbo system and withstand high-speed dives also made it incredibly tough.
Exactly. Survivability was baked in. The sheer mass and rugged construction acted like armor. Hits that would have disintegrated a Messerschmitt or a Spitfire, as the Analysys said, were absorbed by the Thunderbolt.
How did German intelligence react to reports like this?
Initially, disbelief. They thought it was Allied propaganda. But as more P-47s came home looking like flying Cs, they had to accept it. They had fundamentally underestimated the durability that American industrial design could achieve. Their assumption that agility required fragility was just wrong.
Okay, so the P-47 could take a punch like nothing else, but it could also deliver one. Let's talk firepower.
Oh yeah, the shredder, they called it. 8 50 caliber Browning M2 machine guns, 4 in each wing. That's a lot of guns.
8.50 cals. Compare that to the typical German setup.
Germans usually relied on a mix, maybe 2 or 4 machine guns and 1 or 2 20-millimeter, even 30-millimeter cannons. Cannons hit hard. One shell could do massive damage if it hit a critical spot. But they had very limited ammo, maybe 120 to 200 rounds per cannon. You had to be precise.
Whereas the P-47...
The P-47 carried a huge ammunition load, around 300 to 400 rounds total. And with 8 guns firing together, the combined rate of fire was something like 6,000 rounds per minute. It wasn't about one big punch. It was about an overwhelming, continuous stream of heavy metal slugs.
And the effect on target?
Devastating. The sources talk about the firepower converging at a set distance, say 300 yards. In that zone, the sheer density of .50 caliber rounds could literally cut a Messerschmitt wing off or saw the fuselage in half in just a second or two of sustained fire. It didn't just penetrate, it pulverized, shredded, ripped things apart.
And pilots could keep firing for much longer.
30 seconds or more of continuous fire. In a dogfight, that's an absolute eternity. It gave American pilots a margin for error that German pilots nursing their cannon ammo just didn't have.
There's that account from the Regensburg raid.
Right, August 1943. Major David Chilling's P-47 group attacked a formation of Me-110 heavy fighters, twin-engine bomber destroyers. They shot down 8 of them in less than a minute.
Less than a minute.
A surviving German gunner, a man named Roth, described it graphically. He said the Me-110s just came apart, shredded into metal confetti in 2 seconds. There was simply no defense against that volume of fire.
And there was even a psychological sound element later on.
Yeah, with the later models like the P-47D-22, they introduced new propellers, the Hamilton Standard paddle blade props. Because of their size and the engine power, the tips of these blades would actually approach or exceed the speed of sound in certain conditions, creating this distinct, deep, guttural rumble. German ground troops learned to fear it. They called it Donnerschlag thunderclap. It meant thunderbolts were around and usually attacking ground targets with bombs, rockets, and those 8 guns.
Okay, so incredible toughness, overwhelming firepower. The same basic philosophy, survivability plus hitting power, that's what made the Hellcat so dominant in the Pacific, too.
Absolutely. The F-6F Hellcat was Grumman's answer to the Zero, but it wasn't trying to be a Zero. It used the same engine as the Thunderbolt, the R-2800, giving it immense power.
But it was still much heavier than the Zero.
Oh, much heavier. Loaded, it was about 12,000 pounds, roughly double the Zero. But American pilots were trained not to dogfight the Zero on its own terms. No turning fights at low speed.
Instead, they used energy fighting.
Exactly. Use the Hellcat's superior power to climb above the Zeros, then dive down in high-speed slashing attacks, boom and zoom. Hit hard, use the speed to climb back up, reposition, and do it again. Never get slow, never let the Zero use its agility advantage.
And the Hellcat could take hits that would destroy a Zero.
Night and day difference. The Zero was built incredibly light, using this special alloy called extra super duralumin. Great for performance, terrible for durability. No armor for the pilot, no self-sealing fuel tanks initially. A few hits from the Hellcat's 6.50 calibers, and the Zero often just burst into flames or disintegrated.
Where's the Hellcat?
The Hellcat was built like a tank in comparison. Over 200 pounds of armor plating just for the pilot, rugged structure, self-sealing tanks. It could absorb significant damage and still bring its pilot home. Again, survivability was paramount.
And the combat results reflect that starkly.
Unbelievably so. The final kill ratio for the F-6F Hellcat against Japanese aircraft was 19-1. 19 enemy planes shot down for every 1 Hellcat lost in air-to-air combat. Over 5,200 kills credited to the Hellcat. That's not just pilot skill. That's systemic dominance built on a superior fighting machine designed for survivability and firepower.
Okay, the Thunderbolt and Hellcat established dominance through toughness and firepower, but there was still a huge problem, especially in Europe range.
A critical problem. The P-47, for all its strengths, was thirsty. Its combat radius just wasn't enough to protect the heavy bombers all the way to targets deep inside Germany and back.
And this led to what the sources call the deadly arithmetic for the 8th Air Force bombers?
Absolutely. They could only provide fighter escort partway. And the Luftwaffe knew exactly where the escorts had to turn back because of fuel.
This came to a head on Black Thursday, didn't it? October 14, 1943.
The second Schweinfurt raid. A devastating day. The target was crucial ball-bearing factories. But it whizzed deep in Germany. The P-47s and P-38 Lightnings could only go so far, maybe 375 miles out.
And beyond that point?
Beyond that, the Luftwaffe was waiting. They called it the golden moment. Unescorted B-17s flying relatively slow and straight. It was carnage. The Germans threw everything they had at them.
The losses were horrific.
77 B-17s lost or damaged beyond repair. 600 American airmen killed or captured in a single mission. It was unsustainable. The entire strategy of daylight precision bombing was genuinely at risk of failing because they couldn't protect the bombers all the way.
They needed a long-legged fighter, and the answer came, somewhat unexpectedly, from putting a British engine into an American airframe.
The P-51 Mustang, originally designed by North American Aviation for the British, actually. The early versions used an American Allison engine, which was decent down low but really lost power at high altitudes.
Not ideal for escorting high-flying bombers.
Not at all. But then, in 1942, a Rolls-Royce test pilot named Ronald Harker had a brilliant idea. He saw the potential in the Mustang's sleek airframe and suggested fitting it with Rolls-Royce's own superb high-altitude engine, the Merlin 61.
The same engine family used in the Spitfire?
Exactly.
Yeah.
But the key was the Merlin 61's two-stage, two-speed supercharger. That was the technological leap.
Explain why that two-stage supercharger was so important compared to the Allison's single stage.
Okay, think of it like gears for compressing air. At lower altitudes, you need less compression. At very high altitudes, the air is incredibly thin, so you need much more compression to feed the engine enough oxygen. A single-stage supercharger is a compromise. It's not optimal at either extreme. The Merlin's two-stage system could essentially shift gears. The first stage compressed the air, an intercooler cool it down, compressing air heats it up, and then the second stage compressed it again before it went into the engine.
So it could maintain power much higher up.
Dramatically higher. The results were stunning. Fitting the Merlin transformed the Mustang. Top speed jumped from around 390 mph to over 440 mph. More importantly for escort duty, the operational ceiling leaped from about 31,000 feet to well over 42,000 feet. Suddenly, you had a fighter that could outperform anything the Germans had at the altitudes the bombers flew.
An incredible performance boost. But you said the real strategic weapon was its range. How did the Mustang achieve that? It wasn't just the engine, right?
No, the engine was efficient, but the airframe design was the other half of the equation. The Mustang used a radical new wing design called a laminar flow wing.
Laminar flow. We hear that term, but what does it actually mean, and why did it reduce drag so much?
Okay, on a conventional wing, the thickest point is quite near the front, the leading edge. As air flows over it, it tends to separate from the surface relatively quickly and become turbulent, creating a lot of drag, like pulling a rough shape through the air. The Mustang's wing was designed differently. Its thickest point was much further back, maybe 40 or 50% of the way from the front edge to the back edge.
And that kept the airflow smoother for longer.
Exactly. It maintained smooth, or laminar, flow over a much larger portion of the wing surface before it became turbulent. Less turbulence means significantly less drag. The sources say nearly 30% less drag compared to conventional wings of the time.
30%? That's huge for efficiency.
Massive. It meant the Mustang used fuel incredibly efficiently. While the powerful P-47 burned about 100 gallons per hour cruising, the Mustang sipped fuel at only around 65 gallons per hour for similar speeds.
And that translated directly into range, especially with drop tanks.
Absolutely. Once they standardized the use of external drop tanks, those 108-gallon tanks under the wings became common by early 1944. The P-51's combat radius stretched out to 850 miles.
850 miles. That covers.
Look, that was Berlin. All the way to Berlin and back with fuel left to fight. That was the game changer.
So the first time the Mustang showed up over Berlin in force must have been a profound shock to the Germans.
March 4th, 1944. A massive raid, 660 bombers. And suddenly, they weren't alone over the capital. They were surrounded by swarms of P-51 Mustangs. German leadership had genuinely believed it was aerodynamically impossible for single-engine fighters to escort bombers that far. Seeing it happen shattered their defensive strategy.
There's that famous quote, possibly apocryphal, attributed to Reich Marshal Goering.
When I saw Mustangs over Berlin, I knew the jig was up. Whether he said those exact words or not, it perfectly captures the psychological impact. There were no safe havens left for the Luftwaffe.
And this led to a change in Allied fighter tactics, too.
Yes. General Jimmy Doolittle, commanding the 8th Air Force fighters, issued a pivotal order. Mustangs were no longer just to stick close to the bombers, they were unleashed. Their new mission: seek out and destroy the Luftwaffe wherever they could find it in the air, on their airfields, anywhere.
Taking the fight to them relentlessly.
It was the beginning of the end for the Luftwaffe as an effective fighting force. The P-51 didn't just achieve air superiority. It enabled the systematic destruction of Germany's ability to wage war from the air, clearing the skies for the final phases of the war.
So we've seen the technological leaps, the shift in tactics. But this final part of our deep dive really gets to the core of how the war in the air was won. It moves beyond individual dogfights to the brutal, cold mathematics of industrial production.
This is where the sheer scale of American industry becomes the decisive weapon. It fundamentally changed the nature of the conflict, didn't it? It wasn't just warrior versus warrior anymore. It became a process of industrial attrition, almost like an execution carried out by factories.
The production numbers are just mind-boggling when you look at them.
They really are. Republic Aviation turned out 15,683 P-47 Thunderbolts. North American Aviation built 15,486 P-51 Mustangs. 15,000. At peak production, a brand new P-47 was rolling off the assembly line literally every hour.
Every hour, and these weren't simple machines.
Not at all. The P-47, for example, had something like 65,000 individual parts. That complex turbo supercharger system, the massive engine, these were sophisticated, high-performance aircraft being mass-produced on a scale the Axis powers simply couldn't comprehend, let alone match, especially under constant bombing pressure themselves.
And this industrial disparity created moments that must have been utterly demoralizing for the enemy.
Absolutely. There's a stark example from Operation Bodenplatte, that last-ditch German surprise attack on Allied airfields, New Year's Day, 1945.
Right. They caught the Allies on the ground.
They did. At one airfield, Y-34 in Belgium, they managed to destroy 22 P-47s lined up on the tarmac. A captured German pilot was apparently quite proud, boasting about the damage they'd inflicted.
And the American response?
Major George Brooking, the base commander, gave a response that perfectly illustrates the grim reality. He basically pointed to where replacement aircraft were already being uncrated and assembled and told the German pilot something like, "Yeah, you got 22 of ours. By tomorrow, we'll have 40 new ones flown in. How long will it take you to replace the pilots you lost today?"
Ooh, that's chilling.
It is, because it was true. The loss of 22 P-47s was a temporary setback, replaced within days by the endless production line. But the Germans lost 213 pilots killed or captured in Bodenplatte, experienced pilots they could never replace at that stage of the war. America lost machines. Germany lost its irreplaceable human capital.
And this relentless attrition just bled the Luftwaffe and the Japanese Air Forces dry of experienced pilots.
Completely. The Luftwaffe lost something like 28,000 pilots fighting the Western Allies. Their training system collapsed under the pressure. By 1945, they were sending pilots into combat against seasoned Allied veterans with less than 100 total flying hours, sometimes far less.
Less than 100 hours compared to Allied pilots.
The contrast is stark. The U.S. training pipeline was massive and thorough. By 1944, they were graduating tens of thousands of pilots a year. The average P-47 or P-51 pilot arriving in a combat squadron typically had over 400 hours of flight time, including extensive gunnery practice, instrument flying. They were professionals.
So you had experienced Allied pilots in tough, high-performance aircraft, facing increasingly novice Axis pilots in machines that were often suffering from quality control issues due to rushed production and lack of resources.
Exactly. As one Japanese report bleakly put it towards the end, they were sending children to fight professionals. Japan's once elite pilot training program, which demanded 700 hours, totally fell apart. Lack of fuel, lack of planes, lack of instructors. By 1945, new Japanese naval pilots might have only 40 or 50 hours total flight time.
Which leads us to perhaps the grimmest consequence of this disparity in the Pacific: the kamikaze.
The ultimate admission of conventional defeat. The Japanese military realized that a rookie pilot in a Zero stood almost no chance of getting through a screen of Hellcats flown by experienced American pilots. The Hellcat was just too dominant.
So they changed the equation.
Horrifically, yes. They calculated that if the pilot deliberately crashed his aircraft into the target, essentially becoming a guided missile, the probability of scoring a damaging hit on an American ship rose significantly, maybe up to 30% in some estimates, compared to near zero conventionally.
They treated their pilots as disposable components.
Because the Hellcat had rendered their traditional tactics, their traditional warrior ethos, obsolete against the overwhelming industrial and technological power they faced. It was a desperate, tragic attempt to substitute suicidal courage for industrial deficiency.
And the psychological impact on the surviving Axis pilots, especially the Germans who faced the Thunderbolt day after day, it must have been immense.
Profound. German medical officers actually documented a condition they termed Jabo fever. Jabo was slang for J bomber, fighter bomber, which the P-47 excelled at. Veterans were showing actual physical stress symptoms, anxiety, tremors, panic just at the sound or report of thunderbolts nearby, especially that distinctive Donnerschlag rumble.
Even the aces who had initially mocked them felt it. Priller, the one who called it a pregnant cow.
Joseph Priller. By March 1945, his assessment was very different. He was interviewed for some propaganda piece, but his honest views were considered too damaging to morale to publish. He reportedly said, "The Thunderbolt is the best fighter bomber ever built. Unlimited American production. Courage without resources is just a lab defeat. A complete reversal. Total surrender to the industrial reality."
And post-war reflections from German leaders confirmed this shift in understanding.
Adolf Galland, one of Germany's highest-ranking fighter leaders, admitted it, quite frankly. He said they basically misjudged the P-47 and the American approach entirely. They were stuck in their 1930s thinking about lightweight agility. They didn't grasp that the Americans were designing for a different kind of war, one based on industrial production, pilot survivability, and overwhelming sustained firepower. Galland's conclusion was blunt. We were the ones who didn't understand. The plane that could take punishment and deliver devastating firepower would win. They were right. Outro. So when you really dig into the sources, the story becomes clear. It wasn't that the German and Japanese pilots suddenly lost their skill or courage. They were often brilliant. But individual brilliance just wasn't enough against the sheer weight of the American industrial system, embodied in planes like the P-47, P-51, and F-6F.
Planes designed not just to fight, but to endure, to bring their pilots back, and to be replaced quickly when lost.
Exactly. It was a victory of systems, of logistics, of production philosophy as much as air combat. The side that could innovate, produce, train, and absorb losses faster was ultimately going to win. It was industrial efficiency versus individual excellence, and industry won.
There's a final haunting quote from Saburo Sakai, the Japanese ace, who initially laughed at the Hellcat. Reflecting after the war, he said something incredibly profound about the Hellcat's dominance.
What was that?
He said, "Every Japanese pilot who survived the war survived because a Hellcat pilot chose to let them live. That is the ultimate defeat existing at your enemy's discretion."
Wow. That says it all, doesn't it? Complete dominance.
It really does. And it leaves us, and you, the listener, with a pretty heavy question to think about. In warfare, when does that kind of overwhelming material superiority stop being just tactical victory and start becoming something else, almost a form of moral subjugation, where survival depends entirely on the victor's choice? Something to ponder.